Hi, in this video I'm going to show you how to add, subtract, and multiply polynomials. Let's start with adding polynomials. When we add polynomials, it really is just a matter of adding and combining like terms. Whenever I have parentheses with no number in front, I know I can always put a 1. So if I go through and do the distributive with this first one, and then I have a positive 1 that I'm going to multiply through the second set of parentheses with, I end up with 5x squared plus 3xy minus 8y squared, and then I have a plus 2x squared plus 19xy plus 9y squared. So you see that when we added polynomials, I really didn't change any of the signs in front of any of the terms. I just ended up with the exact same terms. Now we are at a point where we've done this before. We have to combine like terms. So if I'm going to do that, I'm going to look for all the like terms and I'm going to circle them. I've got a 5x squared and a positive 2x squared. If I add those together, I get 7x squared. Then I cross them out because they're done. Then I have a plus 3xy and a plus 19xy. When I add those together, I get 22 plus 22xy. Cross those out because I'm done with them. And the final like terms are a minus 8y squared and a plus 9y squared, which when I add them together gives me plus 1y squared. And that's the sum of those two polynomials. Let's look at another example. Here's another example. I'd like you to turn the video off and take your scratch paper and work this problem, then start the video again and see how you did. All right, because it's addition, I, in essence, multiplied through by a 1 in front of each of these. So there's like a 1 here, and a 1 here, and a 1 here. So what ends up happening is I get all of my terms all in a row, and I just need to combine the like terms. So instead of circling and crossing things out, what I've done is I've highlighted in different colors the like terms. Now notice that when I did that, I included the sign that was in front of the number because the sign in front of the number belongs to the number. So now when I combine the yellows, 1x cubed, when there's nothing there, I can put a 1. So 1x cubed plus 3x cubed is 4x cubed. 2x squared plus 6x squared is plus 8x squared. A negative 8x and a negative 9x and a positive 4x. Well, when I add these two, I get negative 17 plus 4 gives me a minus 13x. And then for the pink ones, a positive 2 and a negative 2, well, they cancel each other out. So all that's left is a minus 18. So the final answer to my problem is 4x cubed plus 8x squared minus 13x minus 18. Okay, let's move on to subtraction. When I subtract polynomials, I will follow the same process as when I added. If there's not a number in front of the parentheses, I can put a 1. So in essence, what I have going on here is I'm going to multiply through this polynomial by a positive 1. So the terms are not going to change at all. And then I'm going to multiply this polynomial through by a negative 1. Now, if you'd like to make this plus a negative 1, that would be totally fine. We're multiplying through by a negative 1. Okay, so let's write down what we have. I end up with 3x squared plus 2x minus 5, and now, because I have plus a negative 1, I've got to take negative 1 times x squared. So I get minus x squared, minus 1x squared, and then a negative 1 times a positive 6 is a negative 6, so write minus 6, and a negative 1 times a negative 8 turns into a positive 8. Now remember that for any of these minus signs, if you would like to write it as plus a negative 1, plus a negative 6, plus a negative 5, you're totally welcome to do that. From here, the process is the same. I'm going to combine the like terms. 3x squared plus a negative 1x squared is 2x squared. 2x, negative 6x, that's a negative 4x. You can write it as minus 4x or plus a negative 4x. Then a negative 5 and a positive 8 is a plus 3. And there's the answer. Okay, here's another example problem. I'd like you to pause the video, work it out, and then check your answer. The first thing I'm going to do is put 1's in front of both of my parentheses. The first polynomial looks like 1a plus 3bc plus 5c. Now when I go through with the negative 1, I'm going to get negative 2a, then a negative 1 times 3b is a negative 3bc, and then a negative 1 times a negative 6c turns into a plus 6c. Now we just need to combine like terms. When I add the a terms, I get negative 1a. When I add the bc terms, those are opposites, so positive 3 minus 3 is 0, so I get 0bc, which is just 0, and then I have 5c plus 6c is a plus 11c, and there's the answer. The third thing we're going to do in this video is multiply polynomials. Now, when you multiply polynomials, we're going to look at basically 3 types. I'm going to multiply 2 monomials together, I'm going to multiply a monomial times a polynomial, and we're going to multiply 2 polynomials. So let's start with monomials. When we worked with exponents, we already multiplied monomials together, so this should be totally reviewed. 2 times x cubed times 6 times x squared. This is all multiplication. I could put a multiplication dot here and here. And I have 2 properties, associative and commutative, that tell me I can multiply these in any order that I want to. So first I would multiply 2 times 6 and get 12. Then I would multiply x cubed times x squared and get x to the 5th. Because remember that this all together equals 2 times x times x times x times 6 times x times x. Here's your x cubed, here's your x squared. Altogether, I've got 5 x's being multiplied. So when we multiply and the bases are the same, we just add the exponents. Okay, here's the next example problem. I'd like you to work it out, pause the video, and when you're ready, start the video again and see if you get the right answer. When you multiply, you can either use the dots or you can use double sets of parentheses. You always have an implied multiplication symbol when you have parentheses right next to each other. Now, I know you're not going to do this on your paper, but just to go over what this means. I don't have dots in between all of these, but I could put dots because everything's being multiplied. And if everything's being multiplied, I am free to rearrange them as I want. So when I look at this, it's all multiplication. I take 2 times 3 and get 6. Then I have an x to the 5th and an x. If there's no exponent, you can always put a 1. So x to the first times x to the fifth, altogether I've got x being multiplied 6 times. And then I've got y times y. And again, if there's no exponent on a variable, you can always put a 1. So y to the first times y to the first is y to the second, and there's the answer. Okay, here's the third example. It's a single term raised to an exponent. So see if you can remember how to do the exponents along with the multiplication. Pause the video, work it out, and then check your answer. All right, when you have an exponent outside parentheses, it tells you to multiply what's in parentheses times itself 3 times. So to work this one out, I wrote it down 3 times, and now I'm going to multiply. 7 times 7 times 7 is 343. X cubed times x cubed times x cubed has x being multiplied a total of 9 times. And then y times y times y, remember I can put a 1 for the exponent if there's not one listed. So altogether, I have y being multiplied 3 times. Okay, this is the same problem. I want to give you an alternative solution because we also had a rule for exponents that says if I have a product raised to an exponent, I can put that exponent on each of the factors within that product. Which means I've got 3 numbers being multiplied, so all 3 of them are going to get the exponent of 3. Then I can continue with my rules for exponents. 7 times 7 times 7 is 343. When you raise an exponent to an exponent, we multiply the exponents, and y to the third. This is a quicker way to get to the solution, but I never want you to be afraid to just use the definition of exponents to write something down a certain number of times and do the multiplication that way as well. Okay, now we're going to take a look at multiplying a monomial times a polynomial. So a polynomial in here could have as many terms as you wanted to. Now, a lot of the things that we're doing in this lesson really are review. We know how to multiply a monomial times a polynomial because we've already learned the distributive method. I need to multiply this monomial times every term in the polynomial. So 3a, and I can think of that as 3a to the first. 3a to the first times 3a to the second is 3a to the third. Now I have a 3a times a negative 5a gives me a minus 15a to the second because I have a times a. Then I have 3a times 2, 3 times 2 is 6, times a. There's the solution. Okay, here's the next problem. I'd like you to pause the video, work it out, and then check your answer. All right, here goes the answer. I'm going to take the first term times 3x. I take 7 times 3 is 21. X to the second times x to the first gives me x to the third. And then y, there's nothing to multiply the y by, so it just remains in my product. Second part, I've got a positive times a negative, so I know it's going to be a minus. 7 times 9 is 63. And then x squared, nothing to multiply the x squared by, so I'll just write the x squared down. And then y to the first times y to the fifth gives me y to the sixth. And there's the solution. All right, here's a new kind of problem. I've got a binomial times a binomial. When I multiply two binomials, what I need to do is double distributive. So I'm going to multiply through by the 2x first. 2x times 3x, 2 times 3 is 6, x times x is x squared. And then 2x times 4 is a plus 8x. Next, I'm going to multiply through by the 5. I have a positive 5 times a positive 3x, that's plus 15x, and then a positive 5 times a positive 4 is a positive 20, so I write plus 20. Now for my final answer, I'm going to just want to combine all the like terms like I've done before. I have 6x squared, and now I can add the plus 8x and the plus 15x, and I get plus 23x, and then I also have a plus 20. So my final answer is 6x squared plus 23x plus 20. All right, now I want to show you a nice little trick to help us remember how to make sure everything in the first binomial gets multiplied with everything in the second binomial. It comes from a simple little word called FOIL. F-O-I-L. F stands for first. So I multiply the first terms in the binomial. The first term of the first binomial and the first term of the second binomial. We know from before that that gives me 6x squared. Then I multiply the outside terms. The outside terms would be 2x and 4. So a positive 2x times a positive 4 would give me plus 8x. The next letter I stands for inside. The inside terms would be the plus 5 and the plus 3x. So when I multiply them, 5 times 3x is 15x. So I write plus 15x. And then the L stands for last. That would be the last term of each binomial. The plus 5 and the plus 4, that gives me my plus 20. So again, my answer is 6x squared plus 23x plus 20. We will use the word FOIL quite a bit. I will refer to that many times, and we're going to learn how to do this backwards and forwards. So FOIL stands for first, outside, inside, last, and it's what we use when we multiply two binomials. Here's the next sample problem. Pause your video and work it out. Okay, let's see how you did. Multiply the F and get 5x squared, the O and get plus 7x, the I minus 40x, and the L is minus 56. Now you don't have to multiply in that order, F-O-I-L. It's just a simple way to keep track to make sure you've actually done the double distributive. Every term in the first binomial must be multiplied with every term in the second binomial. And when we combine our like terms, that's what we get as our answer. Okay, here's the last type of problem we're going to do. It's a binomial times a trinomial. Now this could be two trinomials or trinomial and a 4-term. It doesn't matter. What is important here is I have two polynomials times each other. When you multiply polynomials, you need to make sure that every term in the first polynomial gets multiplied times every term in the second. So I'm going to go through and multiply and get 3x to the third, and then minus 4x squared, and then plus 9x. Remember that there are 1's here if you want to put them down there. Okay, now I'm going to change the color and I'm going to multiply through by the second term, which is the plus 2. And I have to multiply here and here and here. So I end up with plus 6x squared minus 8x plus 18. And then from here, it's just a matter of combining the like terms. When I combine the like terms, I'm just going to look at the x cubes. Looks like I've just got 1x cubed, so I'll write that down. And I have 3x cubed. Now I have a negative 4x squared and a plus 6x squared. That's plus 2x squared. Then I've got a plus 9x and a minus 8x. That's plus 1x. And then I have a plus 18. And that would be my answer. Okay, I just want to show you this problem because this is a trinomial times a trinomial. And again, what has to happen here is every term in the first polynomial has to be multiplied times every term in the second. So I multiplied through with red when I took the x squared and multiplied it all the way through. I used blue to multiply the 3x all the way through, and I used green to multiply the plus 2 all the way through. And you can see in the color coding, I ended up with 9 terms here, but when I combine the like terms, I get a nice final answer. Here's the last problem. I'd like you to multiply it and then check your answer against what I have here. So take a look at my answer and see how you did. Multiply through by the x, then multiply through by the minus 6, list all your terms, and then combine any like terms for your final answer. Okay, so there you go. We've added polynomials, subtracted them, and multiplied them. You have all the skills you need to do all 3 of these based on what we've already done this year. So this should be a pretty easy lesson for you to work on this week. Have a good week, and we'll see you next week.